Hello guys, welcome to another session of Mate Math. I hope you guys are doing good. Well, I believe many of you remember this question. You know, we didn't solve the question alone, but we did together with what? Cube root of 4 this in a previous video, right? Where remember where I said I want to show you the difference integral of square root of tangent x and then integral of cube root of tangent x. Remember that video? And also remember that during that video or in that video I promise you that I will give you the derivative of what? Integral of answer to the integral of square root of what? Tangent x, just to confirm our answer, all because of the workings or how we solve the question. Yeah, remember that was what I said in that video. Okay, so today in this video we are just going to differentiate the answer that we have to this integral problem. And someone may ask, if you are going to do differentiation, why are we seeing this, or why this one here? The motive of bringing this one here is just to recall you what we did in our previous video, so that when we are solving the questions and then you want to make reference, you know where you are going to. Okay, so this one just to recall you what we solved the other time, the answer that we had, and then um and then also all right, so and then I'll also help you when you are all making your reference. I mean, when I say reference, when I just bring the answer to this one without showing you this one here, I say we are just going to differentiate that. Though I will just say that this one was the answer we had to a particular integral problem, but some of us will still find it difficult what recalling. But when I show you this and I give you the answer, oh, you easily what recall what we did in our previous video. Or if you maybe after watching this and you want to go back to that, you want to find out how we got the answer to this problem, you easily know where you are what going. I'm saying this because when the answer is just written down for you and you are to search for each problem, you find it difficult doing so, because there are a lot of integrals that we have solved, which we differentiated the answer to find out if you can get the question we integrated back. So in this case, what you are telling me, where should I locate the integral problem? So this is the reason why I decided to show you this. Seeing this just will remind you what we did. Okay, so if you have already reference to that video, and then maybe have gone through and they're just going to relax and enjoy how we are going to I'm just going to uh, sorry, okay, just going to solve, or how we are just going to solve this problem. yeah, I hope many of you have just make reference, recall, I mean, the workings that we did. The workings was something else, do this, do this, blah 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 blah. There was something else. So all those workings that we did, the answer that we had, is it true that when we differentiate it, is going to give this one back after changing, bringing, doing all those stuff? Well, that is why I'm going to show you everything in this video. Okay, guys. All right. So now that we know what we are going to do, and then everything being set, why don't we get started? Okay. So let's get started. First, I'm going to write the answer that we had to this integral problem for you guys. Okay, that is what we are going to do actually, and not this one. They have already talked about it. I'm not going to reiterate myself. So I'm going to write down the answer we had for this one so that you know what we are going to do. Is differentiation, derivative, okay, not integral. All right, so let me write down the answer down for you guys. Yeah, you remember in that video, this was the answer that we had. That is, someone may ask, I hope some of you who have some of you who has reference to that video and has gone through just to record themselves will see a little bit difference in what they saw and what they are seeing here right now. And that is not something to confuse you, because in that video, remember I said that because of all solution approach that I decided to do, the answers that we had to this one will not be like what you are seeing here. Though in that video, the only difference is that in that video, this one, what you are seeing here is 1 over square root of 2 tangent inverse of this one. And in that video, the answer that we had was square root of 2 over 2. But square root of 2 over 2 is the same thing as 1 over root 2. Why? Because in that video, because of all solutions, because I wanted to show you every weekend how every answer is what arrived. Because of that approach that I used was the reason why I had the answer to be root 2 over 2 times tangent inverse of this one. This one was the same thing as what was in the other video, but this one here it is 1 over 2, and I'm saying it is this one is 1, that the other one was root 2 over 2 because of the approach that I used. Okay, so if you want to differentiate that one, it's not anything big, and it's not all that different from this. It's just a matter of what? Rationalizing the denominator. 1 over square root of root 2, when we rationalize the denominator, it's going to be root 2 over 2, which is the same thing as what was in the other video. Okay, and someone may ask, why? Okay, if what was in the other video is the same thing as this, why don't you use that one instead of this? Well, it doesn't matter. Even if during our workings we can rationalize this one to get the same thing as that, and then we continue, or we will just solve this one, and when you are doing it on your own, you can just follow the same procedure and you're just going to get the same answer. When we are doing differentiation, one thing that you should keep in your mind, that anytime you have figures and that figures is being multiplied by a variable, you have no problem. If the variable is not something messed up, something very difficult to differentiate, you have no problem. Why? Because anytime we differentiate what a figure is going to give you what? 0. It's like a constant. It's going to give you what? 0. Okay, so either the root 2 over 2 or 1 over square root of 2. When we differentiate it together with this, it's just going to give us what? 0. And when you apply that one, you have to use the product rule. When you use the product rule to differentiate, the figure part alone will give you 0, and the variable part will give you what? The answer that you are looking for. So 5x plus 1. When you were to differentiate this, there is no need to worry. Just put what is attached to the variable somewhere, differentiate the variable, the answer that you get, multiply by the variable, and you are good to go. And if you want to differentiate the figure together with the variable, just apply the product rule and you are good to go. And you apply the product rule on this. The product rule is just telling us that derivative of a plus derivative of what? B. Let me say it that way. You have to call the formula, where we split and it become plus. First, a is going to be the 5 and the b is going to be what? The x. So when we differentiate a, what is a? 5. Derivative of 5 is what? 0. Plus, now derivative of what? X is what? 1. 0 times 1 is going to give us what? 0 plus 1 is what? 1. 0 plus 1 is what? 1. So you see, and okay, now let's use what I just said. I mean, where you just put the figure somewhere and deal with the variable alone. Now let's put the 5 somewhere. Derivative of x is what? 1. Now, sorry, I made a mistake in quoting the formula. Sorry. When you are applying the product rule to differentiate this, it is a derivative of a times what? B plus derivative of b times what? A. Okay, I mean that is what you are going. That's actually how the formula is. Just write y blah 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 blah. Just using the a and b to represent what? The product rule formula. It is what? Derivative of what? A times what? B plus derivative of b times what? A. So now the figure is what? 5. So we differentiate 5, then we multiply it by what? The variable. So the variable is what? X. So derivative of 5 is what? 0. 0 times 5. 0 times x will give us what? 0. Now let's move on to the other one. The other one is derivative of b times what? A. And a is what? 5. So derivative of b, which is x, is what? 1. Now 1 by 5 is what? 5. Now 5 plus 0 is what? It's 5. Now let's check this one where we put x somewhere. 5x, to differentiate, just put the x 5 somewhere, and now let's differentiate the x. Now derivative of x is what? 1. 5 by 1 will give us, that is after, you remember I said when you get your answer from the derivative, just multiply by the figure you put what? Somewhere. So 5 by 1 will give us what? 5. When you compare these two answers, are they not the same? Yeah, they are the same. So anytime you are doing differentiation and you are having figures in it and you think that figures will confuse, just put the figures somewhere, deal with the variables. At the end of the day, whatever you get, just multiply by the figure you put what? Somewhere. I'm saying all that because of what? The difference in what you are seeing here and what was in that video. Here it was root 2 over 2. Now when you want to differentiate, applying the product rule, this one will be 0. This one will give us what? 0. And 0 multiplied by the whole of this will be what? 0. So the only thing that is going to give us our answer is what? Derivative of this multiplied by this. Okay? So actually the derivative will not affect the figure here. Actually it will not affect it when you apply, it will not affect it anywhere. Okay? So in that video it was root 2 over 2 and here is 1 over 2. They are all just the same thing. Even when we use that one or when we use this, you are just going to get the same answer at the end of the day. Okay, so I will urge you to watch this one, and after that just gather all the courage that you need and then sit down and decide to tackle that one with all seriousness you got. And I hope and I bet you are just going to get what? The same answer. You see, the root 2 over 2 will not be giving you any problem at all. Alright, Good. Now that we are clear with what you were saying here and what was in that video, now let's start doing something. And what are we going to do? You already know how we differentiate our problems. Remember, this one, if you want to differentiate this one, we use what? The chain rule. If you want to avoid the figures, if you want to include the figures, you have to use product rule plus what? The chain rule. Yeah, but if you want to avoid the figures, as I said earlier on, I'm just going to use what? The chain rule. And you know, with me, I'm not being fan of what using what the chain rule. Why? Because well, what should I say? I always want a bit my solutions to every problem very simple, to the extent that even someone who has not read mathematics to a very large extent will what understand my problem. Okay, substitution. Even class A students know about substitution. How much more you PhD, something like that, student, whereby you don't know something about substitution. So anytime I use that approach, it makes me feel that, oh, anytime, even when a class A student or maybe a layman pick my solutions and decide to read, a person is what it will be able to understand. That's why I prefer it. Okay, so we are just going to use the substitution approach to solve this problem. Okay, we're not going to use the chain rule, but the chain rule, the substitution approach here is indirect. I would say it is indirect what application of the chain rule, or indirect chain rule. The chain rule is what? The direct formula, and the substitution is what? The indirect formula for what? The chain rule. Why? Because at the end of the day, after you are done with the substitution, after you are done with the differentiation using the substitution approach, you see that the chain rule has been what? Reflected. The chain rule has been what? Yeah, reflected. Okay, so y is equal to 1 over square root of 2 tangent inverse of square root of tan x minus 1 over square root of tan x all over root 2 minus 1 over root 2 tanx. There's a difference between this and this one as well. The hyperbolic function of this one is the hyperbolic function of this. Okay, and this hyperbolic function, if you don't want to use it, remember in that video I show you everything. If you don't want to use the hyperbolic function, you can use what? Natural log to get answer in place of what? This one. Okay, so in place of a hyperbolic function, we use what? Logs, natural logs, whereby you just get natural log absolute value of blah 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 blah. Yeah. All right. So tan inverse of square root of tan x plus 1 over square root of tan x all over all square root of 2. Now you see this one same thing. I just that here is what? Minus, and then here is what? Plus. And I remember, I believe you know, you saw why in the previous video. Okay, good. So we are going to call this one A, and then we will just finish differentiating the whole of this one. We just write whatever we are going to get at the end of the day down, tackle this one, whatever we are going to get from the derivative, just put it down. At the end of the day, we just add the two answers together to find out if you are going to get this one back. Well, guys, what do you think? Let's start doing something. All right, good. So you're going to start with A. This one is A, and then this one is B. Mind you, we will not carry this negative sign along for this one. We just carry this one. Okay, now let's start with what? A. Differentiating A. Now let me write down A for you. Good, this is our A. Yeah, you know, with the chain rule, we will let's say u be equal to this, and then v be equal to this, and then later we multiply by the derivative of this times a, blah 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 blah, and you're good to go. The substitution approach also, we let r be equal, we let a variable be equal to the whole of what we are to differentiate. After that, we do our substitution. Okay, so r is equal to this one, and what are we going to do? Differentiate. But the question is, when we were solving the integral problem, which is what, the square root of tangent x, you saw how we suffered to get our answer. How much more that it will be very, very, very simple for us to write the derivative of the whole of this. Even this one alone, the tangent inverse of, let's say, x, is not that easy. How much more this? So what do you think? That is where the formulas comes in. Okay, so we are going to do substitution. Well, I believe we have been doing a whole lot under the differentiation. So if you can go ahead and write the answer for this one, no problem. All of us, everybody is okay. The most important thing is to get your answer at the end of the day. But if you can't write the answer to the whole of this at once, then you have to do it what? In bit. And that is what I'm going to do for you guys. I hate writing the answer at once. You know, sometimes when you do that, most people find it difficult getting the understanding. With differentiation, though some people say differentiation is very easy, and then also as well as what, integration. But sometimes if you don't take care, the way some of the problems appears to, you know, the way some of the problems are presented, if you don't take care, you won't be able to though you know, but because of how it is being presented to you, you will find it difficult doing. Okay, so I'm just going to do our substitution at the end of the day, and I believe you are just going to make it is going to make the problem very simple, and we'll reduce it to what all of us know better. All right, we are going to let u be equal to, sorry, not u, we are going to let, you can use any variable at all, but I said u, but actually I have to use the variable I used in solving this problem. I didn't use u, but actually we normally use u, so here I'm not going to use u. All right, we're gonna let z be equal to what is here. All of us know why we are doing so, just to make the problem very simple, and also reduce it to what we know better. Substitution. So z is equal to the whole of this, and how you do your substitution also count. How you do your substitution also counts, so be very, very careful. Please mind you. So z is equal to the whole of this. That is square root of tan x minus 1 over tan x all over root 2. You know, when you are having 1 over tan, it is what? Cot. This one too. Yeah, I hope some of you might be wondering, yeah, if I want to replace this one, will this one be equal to square root of cot x? Yes. This one here is the same thing as what? The square root of cot x. Okay, so if you don't want to use this one, you can use cot x, and at the end of the day, you're just going to get the same thing. But for us, let's use what we saw in the previous video. I just want to, you know, be doing what we don't know. All right, so how are we gonna solve this one? Here we can split this one into what, like fraction, because this and this is having what, one denominator. So it is assumed that before this and this came to be subtracted, both of them were having the same what, denominator. You see, there is nothing here, and also there is nothing here, right? So we are going to split it into what, like fraction by writing this one over this and then this one over that. Okay, when you do that, you will differentiate this one over this alone, and also differentiate this one over this one alone. And then at the end of the day, you just simplify the answer that you are going to get to it well, lowest term. But someone may also ask, what if I don't want to split into a like fraction? If I don't want to split into like fraction, what else can I do? Well, you remember I said initially that anytime you are dealing with differentiation, you can put the figure somewhere. Yes. So this one, can we assume that this figure is not there? When we assume this figure is not there, how is this one going to look like? This one is going to be square root of tangent x minus 1 over square root of 4 tan x. Though it is over something, but we are assuming this root 2 is not there. And whatever we get at the end of the day, we just divide it by this root 2. That we can do it that way also. Or we can, to avoid confusing ourselves with this root 2 here, we can bring it here. We can bring it here. That means we multiply through by root 2, and the root 2 here will be taken away by what we multiply through, and here will be root 2 times z is equal to this one minus what, this, which is the same thing as when we assume when this one is not there. Okay, so these are the ways you can differentiate what you are seeing. But in this video, we're just going to I'll not take it off and say it is not. They have to show, though you are seeing it, so you have to still see it in your mind. It is not there, but with your eyes it is there. You know, your eyes will tell you that, although I assume it is not there, but here I'm seeing it, so I have to bring it back. All right, good. So it is not there by sending this one to this side, and then we differentiate this. Okay, you know, when it comes here, it makes this one very simple. Though at the end of the day, we can bring it back to divide, as I said earlier on, and the answer that we are going to get is going to be the same thing as what, when you maintain this here and then split into like fraction and then differentiate. Now let's multiply through by square root of 4 root 2, and when we do that, it's going to give us square root of root 2 times z is equal to here the square root and square root will cancel out, and it will be square root of tangent x minus 1 over tangent x. Good. Very simple, isn't it? Yeah. Hey, don't say no. Don't say no. If you say no, it means you are not following me. It means you are not getting what you are supposed to get. It's very simple. Everybody can differentiate this one. Everybody can also differentiate this one. This one here is not anything far different from this, just that this one is positive and this one is just some negative. Let me put it some way, you know, we can rewrite this one just to look like this, just that this one they are appearing here, when we rewrite they're just going to be negative. Okay, so it's not anything difficult, very simple. So say yes, better, that's the spirit. Now let's move on. Here, remember I said we are assuming it is not there, though you are seeing this. So when you are differentiating, we this one is not a problem. This one we just write what dz and we are good to go. So now, what is the derivative of what square root of tangent x? To differentiate this, first we have to differentiate this one, what is inside the square root sign, and also differentiate what the square root as well. Now when you differentiate the square, it's going to be 1 out of 2 times derivative of this one is going to give us what, secant x squared times, now we differentiate the whole of this one again. Now the whole of this one is just tangent inverse of tan x all raised to the power hot 1 out of 2, and then when differentiated we just deduct 1 from the numerator, the power, which is what, 1 out of 2. So 1 out of 2 minus half will give us what, that is minus half. So when you differentiate this, you're gonna get tan x raised to the power of minus half. And then when we come here, this one we can write it as, applying the negative index law of indices, we can write this one as square root of tangent x raised to the power minus 1. And then when we assume that minus 1 is not there, and then become square root of tangent, it is the same thing as what, this one. By now it is the same thing as this one, but what, being multiplied by negative. Okay, so instead of getting a positive answer, it's going to be what, negative. Good. Now you see, this one was the same thing as well. This, after differences, you see, we had the same answer, but just that this one as well negative. The only difference here is the what is here. This one, when the power becomes negative and you deduct another one from it, the power does what, increase rather than what, reducing. So 1 out of 2 minus 1 out of 2 minus 1 will give you what, minus 3 out of 4, 2, right? Good. Applying the negative index law of indices, this one can be written as what, 1 over, this one can be written as what, 1 over square root of 4 tangent x, which is what, this one. It normally becomes this one when the power is what, negative. Okay, good. So this one here can be written as what, secant x squared over 2 times square root of 4 tangent x. When we come here, the same thing is applied. Secant x squared over 2 times, this time is not 2 times square root of tangent x, but it's rather 2 times square root of tangent x raised to the power 3, is because of what, this 3 here. All right. Good. So root 2 dz over ds, you don't worry, this dx here, at the end of the day you're just going to multiply through on the other side. You're just going to multiply through by ds, and still you will get dz is equal to something times dx, so that we can go back to the x world and the other variable world. All right, good. So what can we do to this? What can we do to this? Well, here, as you all know, LCM. 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 Secant x squared over 2 times square root of what? Tangent x plus secant x squared over 2 times square root of 4 tangent x squared raised to the power 3. We have to apply what? The LCM to solve this. Why are we applying? If you don't apply LCM, this one is not like fraction. This times this is the same thing as what? This. But what is here is not the same thing as what is here. The here is what? Power 1. But here is what? Power 3. So they are not the same. Hence, we cannot apply the rule of what? Like fraction. Therefore, we have to use what? The LCM approach. Though the LCM somehow, you have to use the LCM approach and then we are good to go. So we will multiply this by this plus this times this all over the product of what? This one and then this. Okay, and mind you, this one here can also be written as you know, when this tangent here is raised to power 2, it will just take the square root of. Okay, so we can write this one as tangent x times square root of what? Tan x, which is the same thing as what you are seeing here. All right, don't worry, we will just write that one as we move on. Good. So let's move on. So here we are just going to expand the bracket. We're just going to open the bracket by doing what I just said. That is this one here is same thing as what? Tangent inverse of tan x squared times tan x, and all of them are being squared. So square root of tan x squared times tan x. Applying the multiplication law of Z, applying the multiplication law of Z, it can also be written as well. Square root of what? Tan x squared times square root of what? Tan x. And square root of tan x squared will give us what? Tan x. And when you multiply by the other one, just going to give us 2 times tan x times square root of what? Tan x. Good. This one is the same thing as what you saw in the other step. Okay, don't confuse yourself. You can choose to maintain it and then multiply this one as I said. Though that's what we are going to do here, but yeah, you can choose to we can choose to multiply the other one by this and then this by this and multiply the whole of that. They're just going to get the same thing as what you are all seeing here. All right, good. Now let's do let's apply the LCM. So what is the LCM is just this times what? This. So we multiply this one by this and also multiply this one by this, and then we add what we get in the numerator's position together. Then we divide it by the product of 4, this one, which is what? The LCM. Okay. Good. Sorry for what's happened. Your system was giving me some issue. That is why That's why it's happening like that. Okay, sorry for that. All right, so let's move on here. Um, um, secant x squared multiplied by 2 times tan x times square root of tan x plus secant x squared 2 times square root of 4 tangent x all over 2 times square root of 4 tangent x multiplied by, please here tangent is here, tan is here, here it was what, tan x times square root of 4 tan x, right? As you are all seeing here. So here tan x is here, tan x is what, here, tan x is here. I don't know why it didn't come, but I don't know if the pen even I don't know if I don't know, but just put in your head that tan is here. You can even verify for yourself that here is what tan. So why is that when we are multiplying this one, we are seeing this? Just a mistake, but you correct it when you are penning something down, okay? But to save time, here is what tan x, right? Tan x is here, tan x is here, tan x is here. So at the end of the day, when we multiply the whole of this, I'm just going to get 4 times tangent inverse at 4 times tan x squared, 4 times tan x squared, and I think that one is going to show up in our next step, and I think most of you saw it before I took it off, yeah, something like that. Good. So here what are we gonna do? We cannot factorize. When you open the bracket, also open the bracket, get the same thing as what you are seeing, but when we bring this, we do factorization. Here you can do something, yeah, even if you don't open the bracket, you can still do something. This one is here, and it's the same thing as what is here, and then square root of tangent x is here, and then when you come here, square root of tangent x is here. When we come to the denominator position, we also having square root of 4 tangent x. That means we can factor out square root of 4 tangent x, which can cancel out with this one, right? Good. That is another way. The next another approach is well, I think another approach is I think actually that is what you have to do if you want to avoid finding the product of the denominator first. If you want to avoid that one, that is what you actually have to do. Okay, so you can factor out the square root of 4 tangent x and cancel out with one of these. At the end of the day, I hope I still believe you're going to get your answer. Good. Yeah, sure, sure, sure. Or you can multiply, find the product of the good, or find the product of the denominator, and then write whatever you're going to get there, then you continue. So these are the two ways. First, either you factor out square root of 4 tangent x, cancel out with one of, remember here tangent is here, so yeah, you cancel out with one of these because here it is multiplying, so we can do cancellation. Now when you do that, just going to get 2 times secant x squared plus 2 times secant x squared, which is going to give us what, 4 secant x squared all over. Now when one of them is being cancelled out, here is going to be give us 4 times tan x times square root of 4 tangent x. Okay, that is going to be your next step when you factor out the square root and cancel out with one of these. But if you don't want to do it like that, we can also find a product of this denominator and then move on. So actually here I I said you can factor out the square root of 4 tangent x because um um uh, somebody may try doing so, and because the person didn't see it in this video, we didn't do that one in this video. Actually, that is not what I'm going to do actually, but I didn't do that one in this video. That person might be thinking, oh, then I doesn't mean I'm wrong. No, you are not wrong. Just that what you get and what you are going to get here won't be won't be all that, won't be the same. We will arrive at the same answer at the end of the day, but just that there will be some difference in your answer and what you are going to see here. But at the end of the day, the approach that you use, you have to stick to that approach to the very end. Because of the approach that I'm going to use, when you factor out this one, it won't be the answer that you are going to get in the next step. It won't be all the same. But that does not mean you are wrong. When you do that factorization approach and then you get your next step, you have to apply that one to the very end. Other than that, you find it difficult um, getting your answer. So if you do the factorization for this one, the next step, what you are going to get, make sure in the other aspect also, where necessary, you have to factor out to the square root of 4 tangent x, then do the cancellation so that you get the denominators to be all the same, but who knows? Good. So here I'm not going to do that. I said that because that one is also another way of what solving this one, which is actually easy. Good. They're all the same at the end of the day. Another way is also find the product of this one. All right. So the product of this one is going to give us 4 tangent x squared. Why? Because remember here it was 2 times tangent x times what? Square root of 4 tangent x. So this times this will give us what? Tangent x squared. And tangent x squared will take off what? This square root. And it will be what? Tangent x. And tangent x times tangent x will give us what? Tangent x squared. 2 times 2 give us what? 4. So actually here it's going to be 4 times tangent x squared. Alright? Good. Yeah. Here we factor out the 2, meaning here if you want to go fast you can still choose to 2 is here, 2 is here, 2 times square root of 4 tangent x. Yeah, 2 times square root of tangent x, and I think to take off this whole thing here. Yeah, to just take the whole of this one here will be left with 2 times tangent x times square root of 4 tangent x, right? If you didn't do it that way, just find the product of this one and then move on to the next step as you are all seeing here. So our next step was supposed to be the whole of this one over this, and then the next step supposed to be factor out to do cancellation, but I just chose to omit the whole of this one over this because I've just remember I said here that you can factor out square root of 4 tangent, meaning factorization is what possible here. So if 3 has been factored out here, it shouldn't be something that should confuse you. Okay, maybe here I forgot to attach to this. Sometimes when you are doing something and then all of us, all of us, you all been there before. That does not mean you know what you are all doing. Okay, so that was just by the way. Let's move on. Okay, so here this will cancel out with this 4 here, and that's going to give us 2. That is going to give us 2. All right, let's move on. Now, when you use what I said, I mean multiplying the product of all the denominator, this is what you are going to get at the end of the day. With this one, there is nothing that you can do to this. You have to leave it as it is because there is nothing that you can do to it again. Someone may try replacing this one with identity of this, that is 1 plus secant s squared, blah blah blah, just going to waste it. But if you try the factorization whereby you factor out the 2 times square root of 4 tangent x, you not get something like this. Rather, the denominator here will be what? In the form of what? A radical. Won't be in the form of what? Like this. Okay, good. So since we cannot do anything to this one again, then we have to go back to where we said that we are going to assume something is not there to help us to differentiate our problem. So after getting your answer, what do? We just multiply it or just divide it by the figure that we assume it wasn't there. So what was the figure that we assume it wasn't there? That is what? The square root of 2. So you're just going to divide through by square root of 2. And when you do that, here will be square root of 1 over square root of 2 times this one will give us what? The z. And then when you come here, it will be the whole of this one times 1 over square root of 2. And that is going to give us this 1 over 2 root 2 times what? Tangent 2 root 2 times what? Tangent s squared. Okay? Then, because we will go back to the x wall to make the application of chain rule possible or seen in our solution, we will equate the z is equal to the whole of this one multiplied by whole dx. All right. Good. Now here there is nothing that we can do again, but someone may ask, I don't understand something here. When we factor out the 2 root 2 times square root of 4 tangent x, and I do the cancellation, the denominator is going to be 2 times tangent x times square root of 4 tangent x. And then what is going to be on the numerator's position will be, let's say 4 secant s squared. I think that one is maybe quite simple than maybe this. To some of us, I'm saying this because of how students sometimes approach questions. Yeah, to some of us. And also when you do the other one, this is what you are going to get. But when you compare this one with the first one, you get what you get what to be on the numerator's position to be very simple, which is what 4 secant s squared, because you get 2 secant s squared, because you just factor out 2 times square root of 4 tangent x, so you get 2 secant s squared. And then when you multiply the two denominators together, you will get it to be 2 times tangent s squared. You see, the first one, the what to be in the numerator's position will be very simple and nice. And then the second one, what to be in the denominator's position is simple and also nice. So any of them that you use, the other one, the denominator will be tangent times blah 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 blah. But here it will be 2 times square root of 2 times tangent s squared. Very simple. Yeah, very simple. But when you come here, very lengthy. Square root secant s squared times tangent x times square root of tangent x plus headache. And the other one to be 2 times square root of 2 times tangent x squared times square root of 4 tangent x, which is what? Headache at the same time. So anyhow you choose, but make sure the approach that you choose, make sure you stick to it. If you don't stick to it, at the end of the day, getting your answer will be what? A problem. So it all depends on you. That is the reason why the other part I said you can do it this way or this way. So the one to choose depends on you. Either you choose the first one or the second one. Any of them that you choose, you're just going to get the same what answer at the end of the day. But here I'm not saying anything here. Yeah, I'm not saying the blah, 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 because the other part, if I say try and avoid radicals, here you are seeing radical here. That is going to bring another question. Okay, so I'm not saying anything here. So make sure the approach that you choose, make sure you are very good. Make sure you can deal with it very well. All right, good. So here, absolutely, there is nothing that we can do to this one again. There is nothing that we can do to this one again. We can neither um, reduce it to we can what else? Well, maybe I don't know, but let me turn to you guys. So yeah, so what can you do to this one again? Yeah, anything rational. If you rationalize this root 2, haven't done anything. If you rationalize this square root of this here, haven't done anything. You're just wasting your problem. So what will you do? Just leave it as it is. Okay, now the derivative of what was in the tangent inverse, what was in the bracket of what the tangent inverse is this. Now what about the derivative of what the tangent inverse? Now let's find out that one also. And remember, at the end of the day, we will multiply the two together, indicating the application of what? The chain rule. Okay, so let's move on to the other part where we will differentiate the tangent inverse. So r is equal to 1 over square root of 2 tangent inverse of z. I've already told you. Forget about 1 over square root of 4 2. Just forget about it. And then with this one, all of us we know answer to it. So focus on the tangent inverse of 4z. Okay. So when we assume this one is not there, what is the answer to the derivative of this? That is what tangent 1 over z square plus 1. 1 over z square plus 1. Okay. Now how do we forget about this? We just, as we did for the other part, we just will bring this one to this side. This one multiplied by 1 will just give us the same thing here. But mind you, at the end of the day, we will just divide whatever we are going to get by our answer because of this one here. Alright, so we will just bring this one here and then we move on. So this one just give us what dr. Remember, this here will be here because I said forget about it. What is the answer to the derivative of tangent inverse of z? That is what? 1 over z square plus 1. Good. You see? Very simple. The answer to this is very simple. Just look at it. Very simple. We are done. Just that we have to do some algebra. Why? Because of the substitution that we did. Very simple. The answer is very, very simple. Good. Now, what are you going to do? It was given to us in what? Totally x word and y word. But we wanted to make the problem very simple by bringing in some variables to help us reduce the problem to it what? To what we know. So, sorry. If we have gotten our answer, we have to go back to what we were supposed to deal with ideally. What is going to replace the z and what is going to replace what z? We did substitution, so z will be equal to something and then the z is equal to something. The other part, the z was equal to secant blah 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 times blah blah. You remember that one? Good. So that one is going to replace what the z, and then remember z was equal to square root of tangent x minus 1 over blah blah blah. Yeah, that one is also coming here. I'm just going to play this one with that, so that all of this will be in what? The r and the x word, which is what? Actually what? The x word. So going back to the x word, we are going to replace z with this one and the z with the secant blah 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 blah, but because of how this problem is, how the workings is, we're just going to do it well, bit by bit. Okay, we just enter the x word small, very small, bit by bit. We first replace this one, then later on we just will replace this one. At the end of the day, we will just write whatever we are going to get at the end of the day down as what? The derivative of what? The tangent inverse of blah 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 blah. First, we are going to replace this one with what? This. Now let's replace it. Good. Good. You have to open the bracket. But before we open the bracket, let's split it into a live fraction before we open the bracket. When we open this bracket directly from here and write the answer down, most of us will begin to mommy, yeah, Charlie, unyana say, unya, I say we, now we cry over, and I don't go through, we say, don't go through, we say, unyana say, what you say, the holy man who you, the way bend day, huh? Yeah, to avoid what I just said, it's in my dialect, don't mind me. It's in my dialect, don't mind me. So, to avoid getting confused, first let's split into like fraction. When we split into like fraction, I think when we expand the bracket, the understanding will be very 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 simple. Everybody will know how we got the answer for this. Okay, now writing as a like fractions, it will be this one over there. It's very simple. When we are having anything in the world over a particular, okay, let me put it this way. When we are having something like maybe a minus or a plus b all over, let's say c, and you are to write that as a single, you have to write it as what? Two different fractions, or you have to reverse the fraction, assuming or provided there is no other figure attaching. I mean, here there is no other figure, maybe two, maybe when you come here there is no other figure. When it is one, it is okay, but when it is more than one, that is where the problem lies. But here, there is no, when there is no other figure, you just write it as the pick the numerators one by one. Just pick the first one over the denominator, which is what? Let's say in this case it is what? A, and then what? B. So here it's going to be A over C. The operating sign is what? The operating sign is not a problem because it is always will be given in the question. Okay. So if it is minus B over C. If it is plus, it will be what? Plus B over C. When you do like that and you are taking it back, like rule of like fraction, then it will just become A plus C or A minus C. I hope you are getting me. So this one is just going to be square root of what? 2, square root of tangent x over square root of what? 2 minus, this is where it's going to be a little bit different, but still you're going to get it at the end of the day. Minus 1 over square root of what? Tangent x over square root of what? 2. I hope you are not confused. Good. Now when you do it like that, you can still further rewrite this one by multiplying, bringing the square root to multiply or the square root of 4 tangent x. And I hope you know why. Why? Because fraction 1 over a divided by c is the same thing as what? 1 over a times what? 1 over c. And I don't know if this is going to be 1 over AC. When you multiply them, just going to be AC. So the same thing is going to be apply here. So here is going to be 1 over square root of 4 tangent x times square root of 4 2. Alright? Good. So as I said, this one is going to multiply, it's coming up here to multiply this one. And it's because of the example that I gave. Good. Let me say something about this one. Square root of 2 times square root of 4 tangent x. From the product rule, you can multiply this and this together and give it 1 square root. That is square root of 2 times tangent x. Or you can still leave it this way, and when you are expanding it, it will still work out. So I'm saying this one because somebody may apply the rule of 4 radicals and then they write this one as well. Square root of 2 times tangent x. That one is okay. But at the end of the day, when you square it, you're just going to get 2 times square root of tangent x. So if you write it as 2 times square root of 2 times tangent x, or maybe this, they are all the same. Alright? Good. Now, I think this one is very simple to expand as compared to the other one. Right? Yeah. So now let's expand it. The coefficient of the two is what? 1, 2, and then 1. Pascal triangles. When you are expanding bracket, which involves more than 2, from above 1 to the coefficients are 1, 2, when it's 3, 1, 3, 3, 1, 4, 1, 4, 6, blah, something like that. Pascal triangle. But we're not doing that here. So let's move on. So first, we will just pick this one and square the whole of this. The whole of this one. So when we square this, it's going to give us what? Tan x. When we square this, it is going to give us what? 2 minus 2 times this one times this one. Okay, so this times this will give us what? This one will cancel out with this one. And then here, root 2 times root 2 give us what? 2. And then, because 1 is here, it will be what? 1 out of 2, and 1 out of 2 times 2 times this 2 will give us what? 1. So actually, this times this will give us what? Minus 1. Then we will pick the whole of this. Please don't pick this one alone. Include this one. Pick the whole of this one. Okay? So we pick the whole of this one. Then we square it. And when we do that, we're going to get 1 over 2 times what? Tan x. This one will give us 2, this one will give us what? Tangent x. And tangent x times 2 give us what? 2 times what? Tangent x. So when we expand this, we're going to get tangent x over 2 minus 1 plus 1 over 2 times tangent x. Okay? Alright? Now what can we do here? Plus 1 here, minus 1 here, it just cancel out. So this and this will cancel out. And to be left with tan x over 2 plus 1 over 2 times what? Tangent x. Now let's reduce this fraction a bit. What can we do? Well, here we can choose to okay, now let's do it. One over tangent x over 2 plus 1 over 2 times what? Tangent x. Well, let's work on this denominator answer. Let's work on it a bit before we bring in what is supposed to replace this. Yeah. Let's work on this a bit. Well, what we are going to do here is that let's use LCM, right? LCM for this one alone. Because if you don't do that, and then we just bring in this computing that fraction, the whole of that fraction will be a little bit difficult. So to avoid that, let's first reduce the whole of this fraction to its lowest term, so that when we bring in this one and then we are working on it, it won't be all that tedious. So here, what is the LCM here? We multiply this by this. It's just 4 times what? Tangent x. So we multiply this by this plus the product of what? This and then this, all over this times what? This. So it's going to give us this times this will give us what? 2 times tangent x squared plus, this times this will give us what? 2. So 2 times tangent x squared plus 1 plus 2 all over 4 tangent x. But remember, the 1 is what? Still there. Good. Now here, from what I said earlier on, that when we have 1 over a over c is equal to 1 over a times 1 over c, where is actually giving us 1 over ac. Sorry, I'm not going to apply that one here. Sorry. So it's like when you are having 1 over a over c, and you want to simplify it, it's just going to be 1 over a times c over 1, and it will give us what? C over a. C over a. So this one will just come up and multiply this one. This one is not like this. It's not like what you saw in the other part, where it was 1 over square root of that one over another one. Right, so this one will come up and multiply this one here, and that will give us what, 4 tan x. 4 tan x. What are we gonna do here? 4 is here. We can do factorization, so we factor 2 out. And when we factor 2 out, that one can cancel out with this 4. So let's do factorization. This will cancel out with this, right? And that will give us 2. So you're gonna get 2 tan x over tangent x squared plus 1. Now this one here, you can replace it with what, secant x squared, or leave it as it is. You don't know what you are going to get in the other part. Okay, good. Now I said we are going back to the x world bit by bit. We suppose everything is supposed to be in what, x world, and not what, x, r, and then z world. Okay, so we have to let application of what, chain rule be seen. So to do that, we have to replace this one with what? With what? With the other one, that is what? Secant x blah 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 times what? Dx. Okay? So we're going to replace this one with what? Secant x squared times blah 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 blah. Good. But let me write that one for you. Okay, so we're gonna replace this one here with this. Very lengthy, but I won't be with that problem. Good. When we multiply this by this, what are we gonna get? When we open the bracket, multiply this one by the whole of this, it's going to be something else. So I think here we are having secant here. We also have another secant here. And then this one here can be replaced with what, secant. So actually we can do something before what? Expanding the bracket. That is, we can factor out the secant x squared, and at the end of the day it will cancel out with what is supposed to be replaced this one, which is what, the secant x squared. Okay, so we will replace this one with secant x squared, and then here we will factor out secant x squared so that that one will cancel out before we will expand the bracket. And also yeah, let's do that one first. Somebody may be thinking of cancel out this and this also, but I prefer we do that one first. Okay. Good. Now here, this and this will cancel out, right? Good. And those of you who were, thinking of cancel out this and this, you see, you can still go ahead and do it. Okay, you can still go ahead and then do it. So doing the cancellation at once, this and this will cancel out, and then also this and this will also cancel. But mind you, this one is what tangent x squared, and this one is what tangent x. So 2 tangent x can cancel out with 2 tangent x here, and to be left with what square root of what tangent x. So at the end of the day, when after doing the cancellation, you're gonna get tangent x times what square root of 4 tangent x plus square root of 4 tangent x all over square root of 2 times what tangent x. Good. What can we do here again? Factorization, I don't think it will be possible. We can't do anything again here. This and this one, there is not. What is here is same thing as what is here, but you don't have anything here. You don't have the same thing here, so it's not factorable. Tangent is here, there's no tangent here, but tangent is here, so it's not factorizable. So what are we gonna do? Well, since we can't do anything to it again, let's put what we assume it wasn't there back. So we're just going to multiply through by 1 over root 2. 1 over root 2. Now when you multiply through by 1 over root 2, this is what we are going to get. So here absolutely there is nothing that we can do to it again, but because this is not the only one that we are doing, we're just going to leave this one as it is, and provided what we started was what we are supposed to do, this will be the answer to it. So the answer to the derivative of 1 over root 2 times tangent inverse of square root of tangent x minus 1 over square root of 4 tangent x all over root 2 is tangent x times what square root of 4 tangent x plus tangent x all over 2 times what tangent x. That is the answer to the A part. Now let's move on to the B part. So let me write that one B for you. We are going to let T be equal to the B, which is what the tanx inverse. The tanx inverse. Here, the same way we work out the A part is going to be what apply here. Just that here is what tanx inverse. So only the tanx inverse will be different from what is here. How we solve the A part, what was in the A part, what was in the bracket of the tangent inverse, it's just going to be the same thing. It's just the same thing, but here instead of the minus, here is what? Plus. Okay, here is what? Plus. Okay, so just a matter of repeating those one but maintaining the positive sign here. Okay, you all know what we are going to do. Okay, because from the other part we have learned something from there. So here maybe we will not waste much time here. So we're gonna do substitution. You're gonna let v be equal to this one. Before we differentiate, let's bring this one here. You already know why. Now let's differentiate. This one just give us the v, but this one will still be there. You all know the answer to this one, also know the answer to this one, but here will be plus, but at the end of the day, the answer is going to be what? Minus. Okay, so when we differentiate this one, it's going to be what? 1 over 2 times secant x squared times what? Tangent x goes to the power minus half, and then this one is going to be minus 1 over 2 times secant x squared times tangent inverse, sorry, times tangent x goes to the power minus 3 out of 4, 2. This one will give us what? Secant x squared over 2 times what? Square root of 4 tangent x. And then when you come here, it will give us what? Secant x squared over 2 times square root of 4 tangent x raised to the power of 3. And then when you open the bracket, it will be minus. This one can be written as well tangent x times what? Square root of 4 tangent x, right? You're going to multiply this by this, and also this by that, and also this by this one. Okay, the other part I told you that the approach that you use to solve this one should be the same thing as what approach that you are going to use to solve this. Other than that, you get two different answers, whereby you have to work further on the other one to get it to be the same. Okay, or whereby you have to use waste other time of going through blah 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 to get your answer. So to avoid that, if you use approach A to deal with a particular problem, to deal with what the A part, make sure when you get here use the same approach. And because of what we use, you're just going to use the same thing here. All right. So here we will just expand this one, and then here we will just factor out what 2. When we expand, it's just going to give us what 4 times what tangent x squared, and then here we can factor out what 2. Good. Let's factor out the 2. 2 will cancel out with 4 and that will give us 4, 2. So here will be what? 2. This one is what? Tangent x squared. Tangent x squared. Oh, this system is giving me a whole lot of issue. We'll be working on it, don't worry. Forgive me on that. This one is what? Tangent x squared. Tangent x squared, you know it is tangent x times square root of 4 tangent x times what? Tangent x. So square root of 4 tangent x times square root of tangent will give us what? Tangent x. Multiplied by tangent x will give us what? Tangent x squared. Okay, so this one is what? Tangent x squared. Tangent x squared. Okay, so here is going to be 2 because this will cancel out with what? The 4 here. Please, it's what? Tangent x squared, not tangent x. Okay, alright. So what are we gonna do here? We can't do anything to it. So we are going to multiply through by what? 1 over square root of 2, and that one is going to give us what? dv is equal to this 1 over 2 times root 2 times what? Tangent x what? Squared. You can't do anything here, so let's move on to where we are going to differentiate the original one. Okay, so t is equal to 1 over square root of 2 tan inverse of 4 v. Let's bring this one here before we differentiate the tan inverse. Derivative of this one will give us what? What is the derivative of what? Tangent inverse of any variable. Tangent inverse of any variable is equal to derivative of tangent inverse of any variable is equal to minus 1 over that variable squared plus 1. Yeah, so it's supposed to be derivative of tangent inverse of 4 any variable is equal to minus 1 over the variable squared minus what? 1. Minus what? 1. You know, when you differentiate tangent inverse, you're going to get the answer to be what? Negative. And instead of, unlike the tangent inverse where you get it to be plus, here it will be what? Minus. Minus. Okay? Good. Now we have to go back to the x word. What is going to replace this one? You know, we're going back to the x word in bit. So what is going to replace this and what is going to replace this? But we're first going to replace this one before we come to this one. Okay? So remember v was equal to square root of tangent x plus 1 over blah 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 blah. Okay? Let me put that one for you. Good. V is equal to this one. So where we are having the 1 over v squared minus, we're going to put this one into that v's position. let's split this fraction before we expand. When we split, it will be this over this plus the whole of this over this. Okay. Okay, so these two will come here and multiply this, and that will give us what, root 2 times what, root tangent root what, tan x. Good. Now let's expand the bracket. When we square this one, it's going to give us tan x over 2. Then now this times this times this 2 will give us what, positive 1, and the whole of this one squared will give us what, 1 over 2 times what, tangent x. This will cancel out with this, and to be left with tangent x over 2 plus or 1 over 2 tangent x. Good. When we multiply this by this to give us what, 2 times what, tangent x squared. This time this will give us what, 2, and then this time this will give us 4 tangent x. This one will come up here, and minus 1 multiplied by 4 tangent x will be what, minus 4 tangent x. Let's factor 2 out from this. When we do, it's going to be 2 into bracket tangent x squared plus 1. Two will cancel out with this 4 to give us what, minus 2. So it will be minus 2 tangent x. And this one we can replace it with what, secant x squared, but we don't know what we are going to get from the original one, from the other one. So let's maintain it before we think of replacing. We don't know what, when we bring what's supposed to replace this one back, when we bring it, we don't know what it's going to be like. Okay, so let's maintain it before we think of replacing it. This one is equal to this, so we're going to replace this one with what, this. What are we going to do here? We can factor out what, secant x squared, right? But does secant x squared match with anything here? No. So we can go ahead and replace this one with what, secant x squared, because of the secant x squared identity to this. So we will replace this one with what, secant x squared, and this way here we will factor it what, out, so that we can do what, cancellation. This one will cancel out with 2 tangent x, and then secant x squared will cancel out with secant x squared, and so you're gonna get minus 1 multiplied by this will give us what? Minus tangent x times what? Square root of 4 tangent x plus square root of 4 tangent x, and we can write it in the other way. That is what? Square root of 4 tangent x minus tangent x times what? Square root of 4 tangent x all over square root of 2 tangent x. Okay, also we can also maintain the negative sign there and leave this one as it is. All right, anyhow you write it, you're just good to go. Either you write it as this, or you multiply this negative through and write as this one minus this. Anyhow, you're just good to go. All right, now here we cannot do anything to it, so what are we going to do? Well, we have to get what we assume it wasn't there back by multiplying through by what? 1 over square root of 4, 2. So when we multiply through by 1 over square root of 2, here will be the t over the dx, and here will be what? Root 2 times 2 give us what? 2. So here will be what? 2 tangent x. Alright, the answer to the other one, which is what? The tanx inverse of the square root of tangent x plus 1 over square root of 4 tangent x all over square root of 2 is minus tangent x times square root of tangent x minus square root of 4 tangent x all over 2 times tangent x, or tangent x, square root of tangent x minus tangent x times square root of 4 tangent x all over 2 times square root of 2 times tangent x. Now we have gotten our answer to all the two we have gotten our answer to all two of them. That is what A and what B. We have gotten what answer to what two of them in terms of what differentiation. So what we are going to do next year is what computation, or we are still going to continue what we are just going to put the two together. That is what computation. If you don't put the two together, we won't be able to figure out the square root of 4 tangent x, because that square root of 4 tangent x has been broken into species and splitted or spread into these two what answers that we are differentiating. So if we don't do this computation to calculate the square root of tangent x calculate that, we will be able to get it back, because it has been splitted or broken into pieces and spread into these two answers. So here some of them is here, square root of 4 tangent x, some of it particles, some of it particles is here. The other part where we have dr over ds, some of them is there. So we have to put it together so that as we move on, it just starts to calculate bit by bit. And at the end of the day, adding, eliminating, doing the computation, we will get the whole thing to be calculated together, and at the end of the day, we just get it back. Alright, so what we are going to do here is computation. Just going to add the A and B together. So add A and B. Mind you, remember initially I said that for the B part it was negative, but I will not carry the negative along, though we had negative answer, but the original question was negative. So when we are doing, now that we are going to do our computation, we have to bring it. If you don't bring it, it will make our answer wrong. Okay, so either you carry it along or you leave it when you are doing your computation aspect, then you bring it. So here just going to carry it along by showing it here. So you're going to be, now that is what it's going to be like. The y over the x is representing the original one, the whole question. I mean, what we were supposed, remember y was equal to a minus b. That is what the tangent inverse of something minus tangent inverse of something. That's what we are supposed to differentiate. So if you are done differentiate this whole thing, we have to see dy over dx because we equated that answer to her. Why? If you don't bring dy over dx, you lose some marks. Okay, so dy over dx is equal to, the first part was a, so a is what, dr over dx. That is what you are seeing here, and the original one, remember, it was subtracting, that is the minus one here. And the b part, it was what we had it to be in, that is what you are seeing here. Even that one is here, dt over dx. This is it. The answer was what, negative. That is why dt over dx is what, negative here. This one is the original one, and this one is what, the answer we had to the b part. Okay, when you open the bracket to be all plus, right? Good. It will be all plus, right? Yeah, sure. Now let's replace this one with what we had, and also this one with what we had. Good. You see? Now the problem is very simple. This one is very simple, you don't waste much time here. And even when I pause here and said I'm leaving it to you guys, go and continue, I hope every one of you will be able to tell me what he or she had, which I believe will not be different from the square root of what, tangent x, because here is just what, a like fraction, and you are just add and subtract, after which you just do some little bit cancellation or radical blah 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 blah, and then you just get your final answer. Okay, should I leave it to you? All right, let's move on. So as you all can see, we are having all two like fractions because the denominators are all the same. So you're gonna write one denominator and we add all the numerators together, right? So you're going to be this one plus this one. You know, this is negative here and this is positive here. It will cancel out to be left with this and then this. And because we are adding, the coefficient of this one will be what, 1, and this one also will be 1. So that's going to be 2, right? Good. This will cancel out with this. This plus this will give us what, 2, right? Good. Guys, remember what I said? Remember what I said, that when I stop here and say you guys should go and continue, it won't be all that problem for you because it's a like fraction. Eh? And after adding or subtracting some, you'll just be able to get your answer back, because after doing that cancellation, adding or after adding or subtracting, the answer will just come by itself. How does it come by itself? That is what you are seeing here. One thing to do, cancellation. The cancellation is even simple. It is simple and clear. What is here is exactly what is here. So just cancel out and to be left with all this. You see, adding and subtracting, doing the computation, you have just calculated the integral square root of 4 tangent x back. It's back, but it's not yet back in full because we are having some strings attached to it. So to get off these strings, we have to do what? Cancellation. And the cancellation is very simple. 2 times tangent x times what? Square root of tangent x divided by 2 times what? Tangent x. What is this going to give us? This will cancel out with this. And what are we going to get? Square root of 4 tangent x, which is what we integrated in our previous video. No matter the approach, or no matter how you manipulate a particular integral problem to get your answer, when you differentiate it, you're just going to get it, but provided you did it in the right way. From those workings that we did, if somebody tells you that at the end of the day, the answer that we are going to get when we differentiate, you will get it back. I think about, in general, not all of us will believe that, oh, we are going to get it because of the workings that we did. Somebody may think that, so when you are doing the workings, you are doing to help you solve your problem. But the next thing is to ask yourself is that, though I'm doing all these things to help me get my answer, but when I get my answer, though I don't know whether the answer I'm going to get is right or wrong, unless I differentiate to find out. When I differentiate, will I get it back based on what I'm doing? Subtract this, using this, cube root, rewrite, change to this, change to blah blah blah, all these lengthy things that I'm doing. At the end of the day, when I differentiate my answer, am I going to get it back? So the answer is yes, only if all those that you did were in the right way. With integrals, if you do it and you don't do it in the right way, sometimes the integrals will agree to give you your answer, but when you are differentiating, the differentiation will tell you that those workings that you did, whatever wasn't the right workings for that particular integral. The answer that you are going to get will tell you that those workings were for this answer that I've gotten, and not for that integral problem that I will integrated. Okay, guys, so when you are solving integral problem and you are doing some workings, just make sure those workings that you are doing, mind you, at the end of the day, no matter the kind of workings that you do, maybe if it is the right way, the integral will just agree and give you an answer back. The integral will sometimes the integral will agree and give you an answer back, but when you are differentiating, you find it you will not get. When you are differentiating, you will not get what you integrated back. So when you are doing these workings, just make sure these workings that you are doing, at the end of the day, when I differentiate my answer, it should give me that answer back. That is, those workings are workings in the right way. When I say workings in the right way, what you are seeing, prefer those workings. I mean, where we integral of maybe this over this. If I do these workings, though in the integral will just agree and give me any answer, but it doesn't suit, or it doesn't match, or it doesn't, it doesn't prefer, it doesn't suit the problem that you are seeing. So guys, make sure whatever workings that you are doing to help you solve your problem will are in the right way. I mean, what you see, make sure what you are doing at the end of the day will match your problem. If you don't match it, or if it doesn't match it, when you differentiate the answer that you had, you won't be able to get it back. All right, good. Now let's continue. So answer to this one is equal to square root of 4 tangent x, which tells us that all those those things that we did to just get that answer was what in the right way. Yeah, all of them were just in the right way. Okay, good. So guys, the answer to the derivative of blah 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 is equal to square root of what tangent x, which is what we solved in our previous video. Yeah, very cool, very cool, very cool, very cool. You see, it wasn't all that difficult, just that we do the way it was presented to us will just put some fear in you. But as you try to start approaching it with all the knowledge in all the knowledge that you have on about differentiation and other things, you see that it's not all that difficult. All right, I believe you enjoy it. Whether you enjoy it or not, we are done differentiating. Okay, good. If you have any question, make sure you leave in the comment section. Alright, okay, good. So therefore, the derivative of, I'm repeating it for you, the derivative of 1 over square root of 2 tangent inverse of square root of tangent x minus 1 over square root of tangent x all over square root of 2 minus 1 over square root of 2 tangent inverse of square root of tan x plus 1 over square root of tangent x all over square root of 2 is equal to square root of tangent x. Square root of tangent x. Wow. Cool, right? Yeah, it's cool. Cool. It's cool. Cool, right? Yeah, it's cool. It's cool. It's cool. It's cool. Hope all news that I hope nothing did confuse you guys, right? Yeah, everything is clear. If everything confuse you, just leave in the comment section and I'll just do my possible best to respond to it for you. All right, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching and I will see you in another video. Bye for now.